Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 3 Calculus. Topic Applications of derivatives. Subtopic Maxima and Minima. First derivative test motivated geometrically and second derivative test given as a probable tool. Simple problems that illustrate basic principles and understanding of the subject as well as real life situations. Exercise 6.5 Part 2 from question number 11 to N. Question number 11. It is given that at x equal to 1, the function this attains its maximum value on the interval 0, close interval 0 to. Find the value of a. Piriba function asi s ki value 1 da maximum value attain tawi close interval asida a ki value putu u haiben. Here f of x is this on the close interval 0 to. Therefore, f dash x is 4x cubed minus 1 to 4x plus a. It is given that f of x attains a maximum value at x equal to 1. Therefore, f dash of 1 must be 0. That is, mataki x asida 1 pisilabadi, we get this expression equal to 0. Then we get a equal to 120, which is the value of the a. For question number 12, find the maximum and minimum values of x plus sine twice x on closed interval 0 twice pi. Here f of x is this, whose derivative is this. For critical points or for maxima or minima, f dash x equal to 0 gives 1 plus twice cos twice x equal to 0. That is cos twice x equal to minus half. And twice x equal to twice n pi plus minus twice pi by 3. N belongs to z. X equal to n pi plus minus pi by 3. N belongs to z. When n is 0, x equal to pi by 3. When n is 1, x equal to twice pi by 3, 4 pi by 3. When n is 2, x equal to 5 pi by 3, 7 pi by 3. Implies x equal to 5 pi by 3, 7 pi by 3 asidi 0 to twice pi close interval asidi yaugdi. The x can take pi by 3, 2 pi by 3, 4 pi by 3, 5 pi by 3. Now, f of 0 close interval asigi n points in the function below putoksi. F of 0 is 0. F of pi by 3 is pi by 3 plus root 3 by 2. F of twice pi by 3 is twice pi by 3 minus root 3 by 2. F of 4 pi by 3 is 4 pi by 3 plus 3 pi by 2. F of 5 pi by 3 is 5 pi by 3 minus root 3 by 2. F of twice pi is twice pi. Thus, maximum value is twice pi. Piriba value mayam singsigi manungdagi twice pi na khwaidagi chaure. At x equal to twice pi and minimum value is 0. Piriba value mayam singi manungdagi khwai pikpudi 0 ni. At x equal to 0. Question number 13. Find two numbers whose sum is 24 and whose product is as large as possible. Number ani putu sum na 24 oiba product na khwaidagi chawba piba ngamba. Let x and 24 minus x be the two numbers. Let px be the product of the two numbers. Then px is x into 24 minus x, which is equal to 24x minus x square. Now its first order derivative is this and second order derivative is this. For critical points or for extreme values, p dash x equal to 0 gives x equal to 12. Now p double dash of 12 is minus 2, which is less than 0. Thus p of x is maxima at x equal to 12. Hence the two numbers are 12 and 12. Question number 14. Find two positive numbers x and y such that their sum is 60 and the x y cube product of x and y cube is maximum. Let f of y is x y cube. Also x plus y is 60. Therefore, f of y is x is replaced by 60 minus y. We get f of y in terms of y. whose first order derivative is this and second order derivative is this. For critical points f dash y equal to 0 gives 45 y square minus y cube equal to 0. Taking out y square, we get this. From this, we get y equal to 45. Y cannot be 0. Now, f double dash of 45, whose value, f double dash of 45, whose value, we get a number which is negative, less than 0. Thus, f is maximum when y is 45 and x is given by 65. 60 minus 45, that is 15. Hence, the two positive numbers are 15 and 45. For question number 15, find two positive numbers x and y such that their sum is 35 and the product x square y power 5 is a maximum. Positive number x among y have ani puto mabani ke sum 35 aduga x square y power 5 purinabagi form the maximum oiba. Similar to question number 14. Question number 16, find two positive numbers whose sum is 16 and the sum of whose cubes is minimum. This is similar to question number 14. Question number 17. A square piece of tin of side 18 cm is to be made into a box without top by cutting a square from its corner and folding up the plates to form the box. What should be the side of the square to be cut off so that the volume of the box is the maximum possible? 18 cm side amaga sangma oiba square sheet amadagi corner sing the square kakthalaga square amamam kakthalaga lemauba makak sing adu lemauba sing adu kongkhatlaga open box ama semgadabani adugumba lemhauriba box adugi maximum volume lehenba matamda kakhatkibi square adugi side amaga sangma kaya oigadagi. Let x centimeter be one side of the square to be cut from its corner of tin. Tin gi corner kuding maktaki kakhat karabi square singi side amagi asang badu x centimeter ohellase. As in this picture, this shaded portion to be cut off from the corner. Let b be the volume of the open bin. Assume na lemhori ba mache singsina kongkhalaga semba box open box adugi volume the b log sille. Then b is what? B the madusu amuk cube mahaki volume the 18 minus twice x 18 sangma side tagi x ani logthoka the 18 minus twice x side amaga sangma adu ore leng breadth na aduga height adu the x to na height orani mahaki adu the length into breadth into height panjalaba matung we get this quadratic, we get a function in x. B is now function of x, therefore dv by dx is equal to this and second order derivative with respect to x is this. For critical points or for extreme points, dv by dx equal to 0 gives, we get a quadratic equation in x. Factorization gives this and solving x can take 3 or 9. Therefore x equal to 3 because x cannot be 9. X equal to 9 is impossible. 18 sangmadagi 18 sangba tin sheet adudagi 18 ani lokthokadi lemhoba aduna open box semanga maroi. When x is 3, the value of the square b by dx square whose value and x is 3, it is a minus less than 0. Thus x equal to 3 is a point of maxima. Hence the side of the square to be cut off is 3 cm. Tingi adugi side is katkada by square gi side amagi asang basi 3 cm oigani. Question number 18. A rectangular sheet of tin 45 cm by 24 cm is to be made into a box without top by cutting off square from its corner and folding up the flaps. What should be the side of the square to be cut off so that the volume of the box is maximum? 17 giduga hairap manai. Let x centimeter be one side of the square to be cut from its corner of the box. Box adugi corner sindagi kakakadaba square sheet adugi side amage sang badu x centimeter lorase. Let b be the volume of the open box. Same with the box adugi phangakadaba volume the b logsilase. Then b is what? 45 sang length 45 to the x and logthokadi 45 minus twice x aduga 20 for breadth na 24 sangmani madugi x ani lokthokadi 24 minus twice x lere mahaki cuboid adugi height adugi x orani. Actual multiplication pangthoba matungda koine cubic expression ama phange. Now dv by dx, x na derivative already we get this. Again second order derivative amasi amuk x na already we get this. For critical points, dv by dx equal to 0 gives what? Gives whose value is this, and factorization we get this, x equal to 5 or 18. X equal to 5 is correct since x equal to 18 is impossible. Masidi impossible oito aroi. When x is 5 second, the value of second order derivative is minus 13, which is less than 0. Thus x equal to 5 is a point of maxima. Hence the side of the square cut off is 5 centimeter. Size corner dagi kakthakadaba square khudungmaki side amage sangmase 5 centimeter oigani. For question number 19, so that of all the rectangles inscribed in a fixed circle, the square has the maximum area. Circle apiba circle amagi manungda yekpa rectangle pumnamoktagi square na khwaidagi area saugani utlu. Let ABCD be a rectangle inscribed in a circle of radius r. Let x equal to AB and BC equal to y. Angle BAC equal to theta. Let a theta be the area of the rectangle. Then a theta is length into breadth x into y. X is what? From right triangle ABC we get AB divided by AC is cos theta. Therefore AC is twice r cos theta, and BC is also twice r sin theta. Therefore a theta is 4r square cos theta sin theta, which can be written as 2r square sin twice theta. Now a theta is function of theta. R is given quantity. Therefore a dash theta is differentiating with respect to theta, we get this. Again it's a second order derivative is minus 8r square sin twice theta. For maxima or minima, a dash theta equal to 0 gives cos twice theta equal to 0, implies twice theta is pi by 2, implies theta is pi by 4. Now a double dash of pi by 4 is a negative number less than 0. Thus theta equal to pi by 4 is a point of maxima. Implies x equal to twice r cos pi by 4, that is root 2 times of r, and y is also root 2 times of r, that is these two are equal, therefore x and y are equal. Thus the area of the rectangle is maximum when the rectangle is a square. Length of breadth ka manarabadi rectangle square ore. Maram sidagi rectangle ki maximum area si rectangle square orakan to a. Proof tori. Question number 20. So that the right circular cylinder of given surface and the maximum volume is such that its height is equal to the diameter of the base. So that the right circular cylinder of given surface and maximum volume is such that its height is equal to the diameter of the base. Let RISB be the radius, height, given surface area, and the volume of the cylinder, then whose volume is pi r square is whose surface area is area of two cross-sectional area plus area of the lateral surface area is in this picture. Now V is function of two quantities. We have to convert it only one variable. Now the ice ki value, the solving ice from the second equation we get this, and multiplying by pi r square we get this. Now dv is function of r, only s is a given quantity. dv by dr is s by 2, and for this 3 pi r square. Again its second order derivative with respect to r is minus 6 pi r. For extreme values we have to put dv by dr equal to 0, gives whose value is this, which is equal to this, and solving we get ice equal to twice r. When ice is twice r, the value of second order derivative is a negative number. Thus the volume of the cylinder is maximum when ice equal to twice r. That is ice is height, twice r is 2 times radius of the base. Hence proof. Question number 21. Of all the closed cylindrical canes right circular of a given volume of 100 cubic centimeters, find the dimensions of the cane which has the minimum surface area. Let BSRS be the given volume, surface area, radius, height of the cylindrical cane. Then volume is given as 100 cubic centimeter. Surface area is twice pi r square plus twice pi r is. Now volume is pi r square is equal to 100. S is equal to this. S equal to this, and ice is what? Ice is 100 by pi r square. We get S is function of r only. Now differentiating S with respect to r, we get this. Again, its second order derivative is with respect to r is this. For maxima or minima, we have to put ds by dr equal to 0. This gives this expression equal to 0. Solving, we get r equal to 50 by pi whole to the power 1 by 3. When r is 50 by pi whole to the power 1 by 3, the value of second order derivative is greater than 0. Thus S is minimum. Surface area is minimum when r is this and ice is this. Ice, giving the value of r in this expression, we get this, and simplifying we get this. Thus the dimensions of the cane are radius is this and height is equal to this. Hence find out. For question number 22, a wire of length 28 meter is to be cut into two pieces. One of the pieces is to be made into a square and the other into a circle. What should be the length of the two pieces so that the combined area of the square and the circle is minimum? 28 meter sangba wire amabu piece ani thongna kakkadabani. Piece amana square semgani, piece amana circle semgani. Adugumba mabani na semba square amasung circle gi area du minimum oiba matamda piece anidugi asangba kaya oigadagi. Let x and 28 minus x be the two pieces of the square and circle. Then ax be the combined area. Then ax is area of the circle. Area of the circle is x by 4 whole square plus area of the square is this. Area of the circle is pi r square. 28 minus x by twice pi, which is the radius, whose square is this, and expanding we get this expression in x. Therefore its derivative with respect to x is a dash x, whose derivative with respect to x is this, and its second order derivative is this. For critical points, we have to put a dash x equal to 0. Putting this corresponding expression, this equal to 0, and solving x, we get 112 by pi plus 4. When x is this, the value of second order derivative is automatically greater than 0. Thus ax is minimum when x is 112 by pi plus 4. Hence, the length of the square wire is 112 by pi plus 4 meter, and length of the circle wire is 28 minus 112 by pi plus 4. That is 28 pi by pi plus 4 meter. For question number 23, prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 times of the volume of the sphere. Prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 times of the volume of the sphere. Largest cone ama sphere radius r oibi sphere amagi manungda largest volume of the largest cone gi volume of the largest cone asidi 8 by 27 times of the volume of the sphere oigani prove to. Let us prove. Let A, B, C, D be the cone inscribed in the sphere of radius r. Radius r oiba sphere magi manung the inscribe tauba cone adu A, B, C, D ayakpa picture asino mahut silase. let V be the volume of the cone. Aduguma cone adugi volume the V loxilasi. Let OX equal to X. Then volume is for cone 1 by 3 pi r square is. R is BC square and AC is its height. There implies B equal to pi by 3 and BC is what? BC is applying Pythagoras theorem in right triangle OBC, right angle HC, and we get BC whose value is root over of r square minus x square, whose square is square, and AC is what? AC is AO plus OC. AO is r plus OC is x. We get this expression, and multiplying x1 multiply we get. Now B is function of x, only r is a fixed number. dv by dx we get this, and its second order derivative is also this. For critical points or for minima or for maxima or minima, we have to put dv by dx equal to 0. Then we get r square minus twice rx minus thrice x square equal to 0. Factorization gives this, and which gives x equal to r by 3 or x equal to minus r. X equal to r by 3 is taken as x equal to minus r is invalid. Length has a negative number tabi yade aduna masim sanade. When x is r by 3, the value of second order derivative is automatically a negative, that is less than 0. Thus, maximum volume is attained when x is r by 3. And maximum volume of the cone is giving the value of x. In the above expression, we get volume of the cone is this, which can be written as I by 27 times of this number. Product of these two numbers gives original value. And the bracketed expression is volume of the sphere. Hence, the maximum volume of the cone is I by 27 times the volume of the sphere. Hence, proof. Question number 24. Show that the right circular cone of least curved surface and given volume has an altitude equal to √2 times the radius of the base. Let us prove. Let SBRL is be the curved surface area, given volume, radius, slant height, and altitude of the cone. Then S slant height is pi RL and volume is B equal to 1 by 3 pi R square S, and L square equal to I square plus R square, as in this picture. Now squaring on both sides we get S square equal to pi square R square L square, and S square is equal to Z, and L square from this L square is equal to I square plus R square. I is equal to 3 pi by 3b by pi R square, and whose square is 9b square by pi square R power 4. Now Z is function of R, only B is a given volume constant. Now dz by dr, differentiating this with respect to r, we get this. Again, it's the derivative with respect to r is this. For critical points, for maxima or minima, we have to put dz by dr equal to 0. That is this expression equal to 0. And solving, we get putting the value of b, also we get r equal to I by √2. When r is I by √2, the value of second order derivative is positive, as these are sum of two positive numbers. Thus, z, that is s, is least when r is I by √2. That is I equal to √2 times of r. That is I is altitude, and √2 times of r is √2 times of radius. Hence, proof. For question number 25, so that the semi-vertical angle of the cone of the maximum volume and of given slant height is tan inverse of √2. So that the semi-vertical angle of the cone of the maximum volume and of given slant height is tan inverse of √2. Cone amagi given slant height leba cone amagi maximum volume oiba sida oiba matamda semi-vertical angle si tan inverse of √2 oigani haba utlu. Let VL theta be the volume, given slant height, and semi-vertical angle of the cone. Then B is what? B is 1 by 3 pi R square. R is CD into ICAC. and CD is what? CD is L sine theta, and AC is what? AC is L cos theta. Therefore, B becomes, putting the value of CD as well as AC, we get this. Now B is function of theta, only L is given value. Now dB by d theta, we get this. Applying product rule on the last two factors, we get this, and simplifying and again differentiating with respect to theta, we get this expression. Get this. Question number 25 continued. For critical points, we have to put dB by d theta equal to 0, whose value is this, which is equal to 0. Factorization gives sin theta is 0 or sin square theta is 2 by 3. Solving theta equal to 0 or sin theta equal to plus minus square root of 2 by 3. Therefore, sin theta is square root of 2 by 3. When sin theta is plus square root of 2 by root 3, the value of the square b by d theta square is a negative number. Thus, volume is maximum when sin theta is this and cos theta is this. Then implies tan theta is sin by cos, we get root 2, and the theta gives tan inverse of root 2. Hence proof. Question number 26. So that semi-vertical angle of right circular cone of given surface area and maximum volume is sin inverse of 1 by 3. Given surface area laiba maximum volume piba cone amagi semi-vertical angle is sin inverse of 1 by 3 oigani haiba utlu. Let B S is R L theta be the volume, given surface area, height, radius, slant height, semi-vertical angle of the cone. Then S is surface area of a cone is this, and volume of a cone is this, and the relation between slant height, radius is this. We get squaring on B, on this term we get B square this. Putting the value of I square from this, we get b square. We have to put b square equal to z, and putting the value of n from this, we get this. Now z is function of r, only s is given value. Now dz by dr this, and its second order derivative with respect to r is again this. For critical points, we have to put dz by dr equal to 0, whose value is this, which is equal to 0, and which gives s equal to 4 pi r square. That when s is 4 pi r square, the value of second order derivative is a negative number. Therefore, z is maximum when s is 4 pi r square. And s is what? S is equal to this. Solving this, we get r by l equal to 1 by 3. R by l is what? It is equal to sin theta, and theta is equal to sin inverse of 1 by 3. Hence, the volume of the cone is maximum when semi-vertical angle is sin inverse of 1 by 3. Hence proof. For question number 27, the point on the curve x square equal to twice y, which is nearest to the point 0.5 is. Curve asigi khwaidagi naknaba apiba point 0.5 tagi khwaidagi naknaba point du makhada piriba option mari sidagi achumba khalo. Let P be a point on the curve which is nearest to the point is. Curve asida laiba khwaidagi naknaba point asidagi khwaidagi naknaba point du P x y lore. Let S be the square of the distance between P and Q. S haibasina P amsu Q gi arapa gi value du gi square du S ka mana hale. Then S equal to applying distance formula, and the coordinates of the point will satisfy the curve. We get this, and S equal to, in terms of S is expressed in terms of y using the x square equal to twice y. Now ds by dy is this, and its second order derivative with respect to y is this. For critical points, we have to put ds by dy equal to 0. That gives y equal to 4. When y is 4, second order derivative is greater than 0, is a positive number. Thus, s is least when y is 4 and x is 2 root 2. The nearest point is 2 root 2, 4. The correct option is A. For question number 20I, for all real values of x, the minimum value of this rational expression is x na lowingba real value lowrabasu rational expression si quite pickpa value di. Let f of x denotes the given function and whose derivative, first order derivative, applying quotient rule, we get this. Simplifying, lastly we get this. And its second order derivative, applying quotient rule, we get this. This further simplification gives, lastly we get this. For critical points, we have to put f dash x equal to 0. Then x square minus 1 equal to 0 gives x equal to plus minus 1. And the correct answer is D. Question number 29. The maximum value of this expression is. Solution. Let fx denotes the given function and its the derivative with respect to x is this. For critical points, we have to put f dash x equal to 0, which gives twice x minus 1 equal to 0. X is half. Now f of 0 is 1, f of 1 is this, f of half is also this. Correct answer is C. See why? P value may am saying quite already 1. The maximum value of this expression be 1, or correct option is C.